All right, so what we're going to talk about today is we're going to kind of wrap up Chapter 9 in one day. So you're definitely going to get just kind of the basic points of Chapter 9. If we have time, we'll come back because it really is a fun chapter. Chapter 9 is about transformations. So let's start off with talking about what a transformation is. A transformation of a geometric figure is a mapping that results in a change of either the position, so where it's at, the size, or could change the shape of a figure. Now, we're going to be talking about two figures here. We're going to talk about the original figure, which is going to be called the pre-image, and the resulting figure is going to naturally be the image. Now, we are going to talk about a little bit of notation today. So let's say our pre-image is a triangle and we call it triangle ABC. The image is going to look like this. So we're still going to use A, B, and C because A is going to be mapped to a new point that corresponds with A. So instead of coming up with brand new points, we're going to change it to what's called A prime, B prime, and C prime. That's what those apostrophe looking things look like. Okay, so we're going to talk about three main transformations today. The first one is super incredibly simple. It is called a translation. So a translation is going to move all points in a figure the same distance and the same direction. So what you have here is you have a picture of a translation. Now, with this, you just see the picture and you can see that this original triangle, the blue one, triangle ABC, started over here on the left, and then the new triangle, A prime, B prime, C prime, is over here on the right. What you're going to be doing today is you're going to be given a pre-image. They're going to tell you how to translate it, and then you're going to do the image. So how you're going to do this, probably the easiest way, if you look at this image, what you're going to look at is a translation maps every point in the same direction and the same distance. So if I look at how A moves from A to A prime, that's how all of the other points are going to move as well. And if you notice, A moves up 4 units, and it moves right 8 units. And if you look at all of the other points, the exact same thing is going to happen. B moves up 4 units, and right, I guess I didn't go up enough, is going to move up 4 units. There we go, 1. Oh man, not cooperating with me. Here we go. 1, 2, 3, 4, right, there we go, 8 units. Okay, so whenever you have the picture, you could just simply take the points and move them up 4 and right 8. But sometimes maybe you're not actually given the picture, maybe you're just given the points. An easy way to map the translation, if you're not given the original image, if you're just given the points, is you can add or subtract the same number to all the x's and add or subtract all the same number to the y's. So what happens here, whenever you go up and down, that's how you're moving along the y-axis. So when you move up 4, you're going to add 4 to your y-coordinate. And when you move right or left, that is, you're moving along your x-axis. So whenever you move right 8, you would add 4 to all your x's. So we won't do it for all of the points, but just for example here, if you were to look at point A is at 0, 6. And notice if I add 8 to my x and add 4 to my y, we would get 8, 10. And if you notice, that's exactly where A prime is. So translations are pretty simple. The next one is probably, I would say, the most difficult one, and it's called a reflection. Now the idea is very simple. It does exactly what you think it would. It's going to flip a figure over a line of reflection, just like you think like a reflection in a water, a reflection in a mirror. So this reflection that you see here is a reflection along the y-axis. The y-axis would be what's called the line of reflection. Now, if you flip a figure, or if you reflect a figure just along the x or y axis, that's pretty easy to do. That's not always going to be the case, but in this one it is. So let's just look at point A to start off with. So point A is at the point 4, 3. And if you look at the point A prime is at the point -4, 3. And And if you look at the point B, it's at 7 comma negative 1. And then if you look at B prime, it's at negative 7 comma 1. So if you look at these, what's happening here, if you notice, the y coordinate's staying the same and the x coordinate is just flipping its sign. So if you are going to reflect across the y-axis, you flip the sign of the x coordinate. And if you are going to reflect across the x-axis, you flip the sign of the y-coordinate. Now, like I said, sometimes you're not going to be reflecting along the x or y-axis. You're going to be reflecting just along another line in general. Sometimes this is easy to do. Other times it can be a little challenging. But what you're going to do, and this is kind of interesting, I think, if it's reflected across the line any other than the x or y-axis, and this is actually true of if the line of reflection is the x or y axis, but the line of reflection is the perpendicular bisector of the segment A prime, B prime, C prime, and so on. Okay, so let's make sense of that. So let's look at the segment A prime. That just means the line that's in between if I were to connect the points A and A prime. This tells me that the line of reflection, so this line here, is the perpendicular bisector of this segment. So first of all, these lines are perpendicular, not really all that useful. What is useful is that this line of reflection bisects this segment here, which means this distance is congruent to this distance. Notice both of those points are 4 units away from the line of reflection. It also works with C, right? C is 2 units from the line of reflection. C prime is 2 units from the line of reflection. And that's going to work for all of those points. So sometimes when you're doing reflections, you're going to have to think about it in that sense. Okay, the last one is going to be a rotation, which I would say is I think easier than the reflections, but maybe kind of seems a little more confusing. So there's actually 3 main ways that you can rotate a figure. So in this example, my pre-image is going to be this triangle over here. So A, B, C. So if you look at, if I were to add the x and y axis here, A is at the point negative 3, yikes, negative 3 comma 1. B is at the point negative 1 comma 4. And C is at the point negative 1, 2, 3, 4, 5 comma 2, negative 5 comma 2. Okay. So what happens with a rotation is you are going to rotate a figure around the center of rotation. So think about a spinner on a game board, okay? So the 3 types of rotations that you can do. The first one is you can rotate 90 degrees clockwise. So what happens here is this point right here is rotated 90 degrees around that point right there. So what happens is the distance between A and A prime, okay, this angle right here is a 90-degree angle, okay? You could do the same thing with the points B and B prime. If it's around the origin, that angle right there is a 90-degree angle, and then you could do the same thing with C to C prime. Once again, if you were to connect those, that's going to be a 90-degree angle. Now, obviously, we're not going to get out our protractors here to measure a 90-degree angle. So what you're going to do is if you have the point of the pre-image, x comma y, if it's a 90-degree clockwise rotation, what you're going to do first is you're going to take the x coordinate and you're going to flip its sign. And then you're going to take the x and y coordinates and you're going to flip their position. So this is what this looks like. If I take A, it tells me I'm going to take my x coordinate, which for point A is negative 3, and I'm going to flip its sign. So the negative 3 becomes a positive 3. And then you're going to flip the x and the y. So it's going to turn into 1 comma 3. Which notice that's exactly where A prime is. You could do the same thing with B. You're going to flip the x coordinate sign, so the negative 1 turns into a 1, and then you flip the x and the y, you would get 4 comma 1, which notice that's exactly where B prime is. You could do the same thing with C prime. Now a similar thing's going to happen if you rotate 90 degrees counterclockwise. So this is same idea, right? A to A prime, that's a 90-degree angle. We're going in the clockwise direction this time. So if you start with the point x comma y, this time you're going to flip the sign of the y coordinate, and then you're still going to flip the x and the y's position. So if we were to if we were to move point A, we would flip the sign of the y coordinate, so the 1 would become a -1, and then you flip the x and the y, so you would get -1 comma -3. Notice that's where A prime is. And we could do the same thing with the other points. For time's sake, we won't. And then the last one, if you do a 180-degree rotation. Okay, so if we look at what this would look like, if you look at A and then this A over here, this is a 180-degree rotation, which if you notice, it's just a straight line. B to B prime, just a straight line. C to C prime, just a straight line. Now, this is a pretty easy flip to make, because you're going to leave the x and the y in their spots, and you are just going to flip the signs of the x's and the y's. So if A is at -3 comma 1, A prime is going to be at 3 comma -1. B is going to be at 1 comma -4, and so on. So I think you're going to want to keep that chart handy for your homework and for our examples over here on the right. So we'll hang on. Don't glue this in just yet. Let's go ahead and do our examples, because you're going to have to glue this in as well. So we want to graph the image of the figure using the transformation given. So the first one should be pretty simple. We're going to translate this triangle HGV, it looks like. We're going to translate it 3 units up and 1 unit left. Now, like I talked about with the translations earlier, if you had the points, so if they had just given you that V is at -1 comma -1, H is at 3 comma 0, and G is at 2 comma -3. When you translate it 3 units up, that means you're going to take your y coordinates and you're going to add 3, because up and down, that's your y-axis. And when you go 1 unit left, okay, left and right, that's your x-axis, and since I'm going left, we would subtract 1 from our x coordinates. Now, since I have the picture, we don't really have to do that. You can just take each of the points and you can go, so if I start with V, and you can just go 3 units up, 1 unit left, and then you can put that point right there and we'll call it V prime. We do the same thing with H. 3 units up, 1 unit left, that's where H prime is going to be, and then G, 3 units up, 1 unit left, that's where my G prime is going to be. So translations are really pretty simple. Okay, the next one is going to be the reflection across the y-axis. Now, I'll show you how to do this. Well, we'll just do it the simple way, I think. Okay, so reflected across the y-axis, that's going to be this axis right here. Now, what happens here is each point, this, remember, is going to be the perpendicular bisector between the pre-image point and the image point. So the first point here, y prime, is going to be really easy to plot, because if your point is on the line of reflection, the new point is just going to be on that line, okay? Now, I think probably the easiest way to do this, if we had x right here and we wanted to plot x prime, if x is 3 units from the line of reflection, x prime is also going to be 3 units in the other direction from the line of reflection. So I think that's probably going to be the easiest thing to do. Notice W is 3 units, so if I go 3 units back the other direction, W prime will be right here. And then if I look at P, P is 2 units, so if I go 2 more units, P prime would be right there. And then once you have your 4 points, you could connect them, and I know it looks a little bit funnier than the last reflection that we did, but that would be that image, that figure reflected across the y-axis. Now, they can get a little more difficult, like I mentioned, whenever you're reflecting along something that is not an x or y axis. So this is wanting to reflect across the line y equals -x. So since it's a negative x, this is a negative sloping line. This has a y-intercept at 0, and this is just a straight line down 1 over 1. It's just that line going in the negative direction, plotting it from there. Okay, couple ways you could do this. I think the ones that you guys have in your homework are simpler than this, but keep in mind that this line of reflection is the perpendicular bisector of the segment that's created between the pre-image point and the image point. So if I start with K, I think the easiest thing to do here is K. If I go straight to the line, I'm kind of going diagonal 2 points. So if I go diagonal 2 points again, that's where K prime is going to be. I'm not really sure a better way to explain that to you guys without actually being there to show you, okay? S should be pretty easy to do as well because it's going to kind of be the same thing. It's going to be 3 points straight there and then 1, 2, 3 points this way. So that's where your S is going to be, your S prime is going to be. And then J, okay, you just have to keep in mind that you are going straight towards the line, okay, because this has to be the perpendicular bisector. So if you were to kind of, okay, eyeball this, it is what we went across 1, 2, 3. I know we went diagonal, we went 3. So if I go 1, 2, 3 again, that new point, that J prime is going to be right there. So my new image is going to look like that. Okay, and then the last one's going to be a 90-degree counterclockwise rotation about the origin. So if they don't give you the points, the first thing you might need to do is go ahead and write out the points because we are going to need them for the rotations. So if I start with point Z is at the coordinates 5, 0, M is at 5, 4, and D is at 2, 1. Okay, so now if you check out that chart over there, it says if your original point is X, y, a counterclockwise rotation, that's going to be right that one down here, you're going to do negative y, x. So I'm just going to copy that down so we have it for safekeeping. So we are going to do negative y, x. So we're going to flip the y coordinate, and then we're going to flip the x and y's position. So if we start with point Z, we're going to flip the y coordinate at 0, so it's going to stay 0, but then I'm going to flip these around. So it's going to be 0, 5. So Z prime will be up there. Okay, do the same thing with M. We're going to flip the 4 to a negative 4 and then flip the x and y. And we're going to have negative 4, 5. That's going to be M prime. And then D, we're going to flip the 1 to a negative 1 and then flip the 2 and negative 1. So we're going to have negative 1, 2. That's going to be point D prime right there. And that's going to be our rotation. Okay. So our last one, and I didn't add this on the left-hand side there, but this is one last, and this is a really simple way to think about this, but this is called a dilation. So a dilation makes a figure bigger or smaller by a scale factor. So if the scale factor is bigger than 1, it's going to make the figure bigger. So if the scale factor is 2, it's going to make the image twice as large as the pre-image. If my scale factor is 1/2, it will make the image half as big as the pre-image. So we are going to need our points here. So if we go ahead and map these out, I don't even have any variables. So maybe we do A, B, and C. A is at the point, negative 3, negative 1. B is at 1, 2, 3, 4, 5, 4. And C is at 4, negative 4. So what we want to do is we want to dilate the triangle by a scale factor of 1/4. So my new triangle, A prime, B prime, C prime, is going to be 1/4 of the size of this. So this is really simple to do. All you're going to do is you're going to multiply both the x and y coordinates by that scale factor of 1/4. So if I start with A, I'm going to take 1/4 times negative 3 and 1/4 times negative 1. When you take 1/4 times negative 3, you'd get negative 3/4. And when you take 1/4 times negative 1, you'd get negative 1/4. So A prime is at negative 3/4, comma negative 1/4, which just going to have to kind of get close. It's going to be about right there. Okay, B, whenever I multiply, once again, each of those by 1/4, when you take 1/4 times 5, you get 5/4, or when graphing, it'd probably be easier to think about it as a mixed number, so that's going to be 1 and 1/4. 1/4 times 4 is going to give you 1. So B prime is going to be at 1 and 1/4, comma 1, which should be right around there. And then C prime, if I take 1/4 of each of those, that should be easy. It would be 1, comma negative 1. So 1, comma negative 1. C prime will be just about right there. So notice that triangle is the same shape, just a little bit smaller.